minutes chemistry. There will always be an exceptions.
Welcome back to another episode of 5-Minute Chemistry. So before we dig deeper to the topic, let me first ask you a question. Have you ever realized how the rules around us constantly make exceptions? Put yourself in this situation. Think of an airport. Boarding processes can be a bit stressful, a bit tiring, and even very time-consuming. So imagine yourself being a 30-year-old single woman and you decided to travel. So in the airport, you were designated and you standed on your designated boarding group, which depends on the flight you booked. However, you suddenly heard from the announcement booth that small children and the elderly will be assisted first since the other airplanes had malfunctioned. So there was this mother with her newborn child, there was a grandmother with her stick and was assisted by her grandchild. And seeing this situation, have you ever realized and think that it's so unfair that the rules suddenly change in that certain moment? Well, you see, the Octet rule is just the same with that situation. Am I right, Jem?
Yes, indeed, they are the same. The Octet rule states that atoms tend to form compounds in ways that give them 8 valence electrons, and thus electron configuration of a noble gas. This rule is applicable to the main group elements, especially carbon, nitrogen, oxygen, and the halogens, but also to metals such as sodium and magnesium. You see, the Octet rule was made to see the stable states of the atoms. However, like in the airport situation, there are certain rules changes that we don't see coming. We can enumerate 3 of them. 1, when there are an odd number of valence electron. 2, when there are too few valence electrons. 3, when there are too many valence electrons. For the first one, let's take for instance nitrogen dioxide. It is a chemical compound with the formula NO2 and obviously does not follow Octet rule. If we exemplify Lewis dot structure from this, a nitrogen will have a lacking electron. If we would determine the total number of valence electrons, 1 nitrogen, 1 times 5, plus 2 oxygen, 2 times 6 is equals to 17. Since nitrogen has an unpaired electron, it will clearly be lacking electron. However, it is still stable. You see, compounds like this question a lot of chemists why the Octet rule was invented in the first place when the compounds does not even follow it.
So moving on to the second violation, when there are too few valence electrons. So a great example for this would be boron hydrides or BH3, in which BH groups occupy the apices of electron deficient clusters. So the term electron deficient arises from the fact that boron has more valence orbitals than it does on valence electrons. So having this said, the term electron deficient makes it violate the Octet rule. So you see, boron has only about 6 electrons around it, and hydrogen can only carry about 2 electrons in its outermost shell. So there are no more spare electrons to form the double bonds for the boron. So you see, the Octet rule is quite difficult to understand sometimes, and there are a lot of things to be considered. So how about you? Do you still see the value of the Octet rule?
That makes me think of second thoughts, Kate. Now let's try to see the third violation when there are too many valence electrons. A great example to this would be the very common phosphorus pentachloride or PCl5, wherein phosphorus has over 10 valence electrons surrounding it. In our past chemistry lessons, we have learned that the Octet rule can easily be identified. However, it has also been stated that for atoms in the fourth period, higher d orbitals can be used to accommodate additional shared pairs beyond the octet. This makes me question even more Gilbert Newton-Lewis on how this rule does not apply to all compounds.
And I approve to that, Jem. You see, chemistry has always been the field of new discoveries, a field of new learning, but imperfections will always be present. But I think that's the beauty of chemistry. You You see, it changes and it teaches us to adapt and to develop resilience, just like the Octet rule. There may be rules in the society, rules in chemistry that makes exemptions on certain situations. But like the most compounds that do not follow the Octet rule, we should also learn to be stable by ourselves and to live by ourselves without following those rules.
And I greatly attest to that idea because, like the Octet rule, life could sometimes be unfair to some and fair to others. Like an ambulance that we see on the road, it could travel up to 25 miles per hour, exceeding the speed limit. However, if you were the one driving in your own personal car and drove with the same speed, you would be ticketed and fined for what you've done. We hope you learned how to make exceptions with the Octet rule, at the same time apply it to your life. That's a wrap for today's 5-minute chemistry.
Bye everyone, and see you on our next episode.